Dear students, welcome. Today we will study superposition theorem. Let's first define what superposition theorem is and how it works. Superposition theorem is based on concept of linearity between the response and excitation of an electric circuit. It states that the response in a particular branch of a linear circuit when multiple independent sources are acting at the same time is equivalent to the sum of the responses due to each independent source acting at the time. In this method, we consider only one independent source at a time, so we have to eliminate the remaining independent sources from a circuit. For example, we have 3 or 4 independent sources in a circuit. Therefore, for checking the response of a specific independent source, we have to kill all the independent sources and keep one source alive. We can eliminate the voltage sources by shorting the 2 terminals and similarly the current sources through opening of their terminals. Therefore, we need to find the response in a particular branch n times if there are n independent sources. For example, if there are 3 or 4 independent sources in the circuit, then we have to find the response of a particular branch through which we are required to find a specific parameter. We have to perform n number of responses on that particular branch. The response in a particular branch could be either current flowing through that branch or voltage across that branch. Now we will discuss the procedure of superposition theorem. You have to follow these steps in order to find the response in a particular branch using superposition theorem. First step is you have to find the response in a particular branch by considering one independent source and eliminating the remaining independent sources present in the network. You have to kill all the sources and keep alive single independent source, either current or voltage. Step 2 is repeating step 1 for all the rest of independent sources present in the network. Step 3 is adding all the responses in order to get overall response in a particular branch when all the sources are present in the network. Let's now continue to our example to further understand the concept of superposition theorem. Consider the following circuit. It has a 20 volt independent voltage source, 5 ohm resistor, 10 ohm resistor, another is also 10 ohm resistor, then it's 20 ohm resistor, and at last there is a 4 ampere independent current source. Now we have to find the current flowing through 20 ohm resistor of the following circuit using superposition theorem. So we have to find the current flowing through this 20 ohm resistor using superposition theorem. Now remember the steps of superposition theorem. Here we have 2 independent sources. One is voltage source and another is current source. So step 1 is let's find the current flowing through 20 ohm resistor by considering only 20 volt source. So we will kill 4 ampere source and we will remain alive 20 volt source. In this case, as I said, we are going to eliminate the 4 ampere current source by making an open circuit. The modified circuit is shown in the following figure. Here we have 20 volt source, 5 ohm resistor connected to rest of the resistors. Here you can see there is only one principal node which is lying right here and the reference node is here, as you can see. So we are going to use nodal analysis on this respective node. So we will get the voltage of the node V1 through nodal analysis. So V1 voltage from node 1 with respect to the ground is going to be found through equation of nodal analysis. So we have V1 minus 20, here we have V1, and here we have 20 volt source. So V1 minus 20 divided by 5 plus V1 divided by 5, here we have 0 potential. So V1 minus 0 divided by 10, and here we have to add both resistors. So we have V1 divided by 10 plus 20 is equal to 0. This equation can be simplified as taking an LCM of 30. So we get 6V1, 20 multiplied by 6, so we have minus 120 volts. Here we are going to get 3V1 and here V1 respectively. So we will move 30 to the right hand side and it will become 0 after multiplication is 0. So we get equation as 10V1 is equal to 120. So we get the voltage at V1 node to be 12 volt. So the current flowing through 20 ohm resistor can be found to this equation, I1 is equal to V1 divided by 10 plus 20. So we have V1, so we will put the equation of V1 in above equation. So we have I1 is equal to 12 divided by 10 plus 20. It will become 12 divided by 30. So we have 0.4 ampere at 20 ohm resistor. Now the same current will flow through 10 ohm resistor as well because both resistors are connected in series. As I mentioned, the current flowing through 20 ohm resistor is 0.4 ampere when only 20 volt voltage source is considered. Now what we will do is to kill the voltage source and find the response of 4 ampere current source. As I mentioned, let us find the current flowing through 20 ohm resistor by considering only 4 ampere current source. So in this case, we will eliminate 20 volt source by making a short circuit. So we are going to get the modified circuit as follows. Here we have 4 ampere circuit connected with rest of the resistor and 20 volt source is short. So in above circuit there are 3 resistors to the left of terminals A and B. As you can see, I have mentioned terminals A and B. At my load are the branch through which I am going to find current. So we can replace these resistors with a single equivalent resistor. So 5 ohm and 10 ohm resistors are connected in parallel and the entire combination is in series. We have to locate from this point because we are moving towards this point in equivalence. So the equivalent resistance to the left of the terminals A and B will be our AB is equal to 5 multiplied by 10 divided by 5 plus 10 plus 10. So we get 13 ohm, 13.33 ohm as our equivalent resistance. So the simplified circuit diagram is shown as follows. We have 13.33 ohm of resistor connected to 20 ohm branch and with a current source. Now we can find the current flowing through 20 ohm resistor by using current divider rule. So this is how we are going to find. Current divider rule states that total current multiplied by Rn divided by R equivalent. So here we have R1 plus R2 and Is is 4 ampere and R1 is 13.33 ohm. So we are going to substitute 4 ampere, 13.33 ohm and 20 ohm resistor in the above equation. We get current as I2 is equal to 4 multiplied by 13.33 divided by 13.33 plus 20. So we get 1.6 ampere after we kill the voltage source and we have the response of 4 ampere current source. Therefore, the current flowing through 20 ohm resistor is 1.6 ampere when only 4 ampere current is considered. Step 3 is adding up the responses of both sources. So we can write it mathematically as I is equal to I1 plus I2. After substituting the values, we get the response or the total current as 2 ampere. Therefore, the current flowing through 20 ohm resistor of the given circuit is 2 ampere. Let's now go to falstad.com/circuit and verify this entire calculation through our simulator. Here we are in our falstad simulator. First of all, we will clear the circuit. So we checked on blank circuit. Now we will start composing our circuit that we had in our example. So there we had resistors. First resistor was of 5 ohm. Second resistor was of 10 ohm. Third resistor was also of 10 ohm. And fourth resistor was of 20 ohm. So we will change the values of resistors. First was of 5 ohm. Second was of 10 ohm. Third and fourth. Now we are going to connect our resistors. We will connect it point to point so that we don't have any trouble while having measurements. We will extend this wire for adding up the voltage source. So now we will go to add and have a 2-terminal voltage source and change its value to 20 ohms. Now remember we had one independent current source as well, so we will go to inputs and take a current source. We have to change its value to 4 ampere. We will connect the current source as well. So this is how our circuit looked like. Now, according to superposition theorem, we have to take the impact of one source at a time. So either we have to kill voltage source first or current source first. So we will proceed as per our example. We will open circuit our current source first. So here I have open circuited it. Now we will check the currents through 20 ohm resistor. Now I will place an ammeter right here. So I'm going to draw output in labels and check an ammeter, place it right here. Here I have 400 milliampere of current. When I convert 400 milliampere into amperes, it is exactly 0.4 ampere. So we had our current 0.4 ampere in our circuit. But in order to understand this entire circuit entirely, I am going to place ammeters and voltmeter at each resistor. So I am going to put one ammeter here to check the current across 10 ampere or 10 ohm resistor. I will place ammeter here as well for checking current across this resistor. I need to move this 5 ohm resistor so as to check its current as well. Now I will connect it. I'm going to place an ammeter right here for checking its current. Now we have currents at each resistor. Now I will put voltmeters as well. I will check the voltages across each resistor, especially at 20 ohm resistor through which we are interested finding current. So I will connect all the voltmeters and check its respective voltages. Now you have voltages and currents at each point in the circuit through each resistor. However, you have to focus on this 20 ohm resistor only. Now, the second step was to open circuit this voltage source and connect this current source with the circuit. So we will do as directed. We will disconnect this voltage source. So I'm going to drag it further from here and I will short circuit this point where we connected our voltage. Now what I'm going to do is connect the wires with this current source. Now you see that we have 1.6 ampere here, so it's proven that our calculations were perfect. We have 1.6 ampere in our calculation and in simulation as well. Now what we will do, we will add up response of both the independent sources. So we will just remove this wire and connect our voltage source. So we have 2 ampere current when we add up both the current and voltage source, and this was what we were interested to prove through superposition theorem. So the simulations are now complete. Let's meet at home task. In home task, you have to verify superposition theorem for the given circuit, and as usual you have to perform all the calculations and simulation stepwise to find the impact of both sources using superposition theorem. So this was all about today's lecture. If you have any problem, feel free to ask. You can email it to me or post it directly here. See you in the next lecture. Best of luck.